Welcome to our YouTube channel once again. This is Amos Mpeche from Top Research Center. Today I want to concentrate on scales of measurement. In my last lecture, I pointed out that in Spss we have three levels of measurement. That is nominal scale, ordinal scale, and then scale. But under scale, we have both equal interval scale and ratio scale. So today I want to look at these concepts and try to explain further so that you could understand what we refer to as levels of measurement in detail. Because for any aspiring statistician, it is important to know the level of measurement or variable is measured at in order to perform appropriate and accurate data analysis on that particular variable. So without much ado, let us delve into today's lecture. So today we are on lecture 2. We are looking at levels of measurement or scales of measurement. To begin with, I want to look at the definition of measurement. In this regard, measurement simply means the assignment of numerals to attributes of objects or events according to rules. So, assignment of numerals to attributes of objects or events according to rules. A simple example we did in our last lecture is when we assigned a 1 to males and then a 2 to females when we were looking at the variable sex. So this is a simple rule which we used in our last example. And again we had the variable age. And in this case, we were looking at age in years. So we had to use a yearly scale when we were looking at ages of our participants. But we could have also used a monthly scale looking at how many months each participant has. So it depends on what you want to look at for when you are assigned a particular scale. But in this case, we assumed that those who were 64 years had reached their 64th birthday. So annually, years do increase as you reach your subsequent birthday. So this is the agreed scale we used when we were allocating ages to individuals who participated in our survey. So as you can see, the way we assigned these numbers and the way we assigned these numbers, we used different levels of scale. Therefore, when you are analyzing this data, you are also expected to apply different statistical procedures or mathematical procedures in order to get accurate results. So it is very important to know that levels of measurement determine what statistical operation or mathematical operations you can apply on a particular variable or on a set of variables which you are analyzing. So as I have already said, we are concentrating on levels of measurement. and there are 4 levels of measurement which we have. And these 4 levels of measurement are nominal, ordinal, equal interval, and ratio. Remember, in SPSS, these are both under scale. So I'm going to look at each and every level of measurement in detail and try to explain so that you can understand what we mean when we're talking of level of measurement. I want to start by looking at nominal measurement. You find that when I'm looking at nominal measurement, this is just a classification of objects or events on the basis of shared attributes or characteristics. You are just naming or labeling the subgroups you have come up with. So it's just classification of events or objects on the basis of shared characteristics. You are designating or giving or assigning numerals to subgroups which you have created. In our last lecture, we assigned 1 to males because they have same characteristics, and we did the same to females by assigning a 2 because they have shared attributes. So you find that it is just naming or labeling. You can easily swap this one and this 2 without making any difference. The other point when you are dealing with nominal level of measurement, you find that there is no relative meaning of these figures attached or assigned to variables. For example, it does not necessarily mean if you assign a 1 to males, males are superior than women, or vice versa. So these figures don't indicate anything about the relative position of the category. It's just identifying the subgroups included. The second level of measurement is ordinal scale. You find that this is a crude form of measurement and the only one possible with many properties used in social sciences. So we have ordinal, which is a crude form of measurement. Numbers assigned are essentially ranks to represent position or order in a series. So numbers are ranks and they show position in a series. In our last lecture, we looked at health status. We assigned 1 to good health, 2 to excellent health, but a 0 to poor health. You find that these numbers are relative to the condition of the participant. Some of the most used ordinal type of measurement scale involve agree and disagree type of statements. So some used ordinal form of ordinal measurement are based on agree and disagree statements. For example, we have different questions in social sciences which elicit attitude responses. In that regard, you find that we have also to assign the numbers to attitude responses relative to the position in the given series. For example, we can have an attitude statement such as Zimbabwe is a welcoming culture, and we have statements such as strongly agree, neither agree, and so on, like in a Likert scale. So you find that these numbers assigned are relative in this series of responses. So you find that when we are looking at ordinal form of measurement, we have to assign these numbers, and then when we analyze, we manipulate these numbers, and that manipulation will also indicate relative position of a particular or of particular responses. It is important to know that when I'm talking of ordinal type of measurement, they only show the order in a series, but we are not concerned about the difference in units between the responses. For example, we are not concerned about showing the relative difference between a 0 and a 1 in terms of units, or a 1 and a 2. In my recent example, I said when you are saying somebody is number 1 in a race and somebody is number 2 or number 3, we don't care by how many units somebody can be assigned a number 1 or number 2. Or again, in this case, we are not concerned about the relative difference in units. So ordinal form of measurement only shows the order in a series. So I have already highlighted that these numbers in the analysis will show relative order of these attitude statements. So intervals between numerals used are not necessarily equal. It does not necessarily mean the difference between a 0 and a 1 or a 1 and a 2 is the same in terms of health status of our participants when we are dealing with ordinal form of measurement. The third level of measurement is equal interval scale of measurement. The numerically equal distance on the scale assigned represent equal distance in the property being measured. In this case, you find that the numeric scale provided can help us to know both the order and the exact difference between the values. So there is numerically equal distance on the scale assigned. And this represents equal distance in the property being measured. For example, we have a variable temperature. In this scale, you find that the difference between 15 and 25 degrees is the same as the difference between 25 and 35 degrees, because the distance between 15 and 25 is 10, and the distance between 25 and 35 is 10. So numerically equal distance on the scale assigned represents equal distance in the property being measured. In this case, we are measuring temperature in degrees Celsius. But if we want to look at the difference between 15 and 25 and 25 and 35, the distance remains the same. That's what that statement implies. So you find that in this case, from a numerical scale provided, we can both order and know the exact difference between the values. In my previous example on ordinal, we were able to identify the order, to say this is number 1, this is number 2, this is number 3, or this is poor health, this is good health, and this is excellent health. But we couldn't give the exact difference between the used units. But in this case, we can order this. From mere looking, you can identify that the lowest temperature was -15, followed by -10, followed by 0 degrees Celsius, followed by 15, followed by 25, and followed by 30. Thus, we can easily order, and we can see the difference that between 25 and 30 is 5 degrees. We can know the exact values between the used units, and also we can order. So this is equal interval scale. And you find that when you have a variable measured at this level, you can perform all mathematical operations or statistical procedure on that particular equal interval scale. So you find that you can perform all statistical procedures when you have a variable measured at this level. The fourth level of measurement is the ratio scale. Ratio scales are the ideal type of measurement scales when it comes to measurement, because they tell us about the order, they tell us about the exact value between units, and they have an absolute 0. So you find when you are dealing with a variable which has been measured at ratio scale, you find that you can have the order, you can know the exact values between the units, and they have an absolute 0. For example, you find that we have age and weight. These are typical examples of variables measured at ratio scale. We have an absolute 0. We can't talk of -0 age or -0 weight. So we have an absolute 0. And the presence of a true 0 means you are able means that we are able to calculate ratios when we have variables measured at this level of measurement. For example, in this case, we can say somebody with 64 years is twice the age of somebody who is 32 years. Or we can say somebody with 50 kgs in weight is twice in weight to somebody who is 25 kgs. Or we can say 32 years is half of 64 years. So you can calculate the ratio if you are dealing with variables measured at a ratio scale. So we have the ability to calculate the ratio since we have true this. When we have these types of variables measured at a ratio scale, you can perform all descriptive and inferential statistics on your particular variable. So when you have variables measured at this level of scale, you can perform a wide range of statistical procedures or mathematical procedures on your variables. In SPSS, equal interval and ratio scales are classified as scale. So I think I have already indicated this several times that equal interval and ratio scales in SPSS are classified as one. So in general, these are the levels of measurement we have. Thank you for watching. Please like, subscribe, share with your friends, and if you have any question, contact me through our YouTube channel, our Twitter page, our Facebook page, or you can contact me directly again on our website using a contact form on topresearchcenter.com. Thank you for watching.